Welcome to a course on sequence and series. In this lecture, we are going to talk about root test and problems related to it. Also, we will see ratio test and problems related to it in the upcoming lecture. Let us get into it. Here, we are given with some series summation an and we are taking alpha to be the limit of the supremum of nth root of absolute an. Right? From the given series, we will have to identify the general term an and take absolute value of that an and find the nth root of that value. Okay, the nth root is taken, the supremum of the nth root is taken, and for which we are taking a limit, right? And that limit we denote by alpha. And if that alpha is smaller than 1, the given series is going to be convergent. That is what we are going to prove in the first part of this theorem. Let us get into the proof. Okay, here this is what you will have to clearly look at it. Okay, it is the limit of supremum, which means what? The entries, this value will be smaller than or equals alpha. Okay, we are given with the information that alpha is the limit of supremum of nth root of absolute an. This implies your nth root of absolute an will have to be smaller than or equals alpha. Okay, this we will have to remember for sure, because this is the idea. This we will consider for proving the upcoming things. Okay, in the first, what is given? We are taking alpha as smaller than 1. Okay, when alpha is smaller than 1, there exists some real value beta such that alpha less than beta less than 1. Since alpha and 1 are real quantities, we can always identify some quantity which is between alpha and 1. For this case, there exists some positive integer big N such that your nth root of absolute an is smaller than alpha for n bigger than or equals n. Okay, here what we are saying is that this is lesser than alpha, right? Here we are saying that alpha is less than beta as well. This is the general term, which means there may be some oscillations and after that it is becoming steady. We have seen some example in the previous lecture, right? Till a certain stage, as the terms are defined in some manner, after that stage they are defined in some other manner. Because of after that stage, the definition were able to give us the convergence, right? Supposing we have some stage like that, that is what we are identifying and having these things. Okay, and this implies what? Absolute of an is less than beta per n. When you take n power n on both sides, you are going to get this, and this is true for n bigger than or equals n. Now, as of now, we are going to consider we have two series, namely summation an and summation beta n. Right? Here, the situation that we have is we are having two series, summation an and summation cn. This cn is nothing but beta n. Okay, beta per n. And we have absolute of an is smaller than or equals cn for n bigger than or equals n. This is the situation we have. And we know that when summation cn converges, summation an also converges. That is what we have proved in the comparison test. Okay. If we prove this summation beta per n converge, then we can easily say that summation an converges. How to do it? Since this beta lie between 0 and 1, okay, here you may see that beta is smaller than 1. And of course we are taking since we are taking absolute and then taking the nth square root, this alpha is going to be a positive quantity, right? Which means we have something of this sort. Therefore, beta lie between 0 and 1. Since this is true, summation beta per n converges. Okay, then by comparison test, our summation an also converges, right? And now let us proceed to prove the second case, that is when alpha is bigger than 1. Okay, the alpha value is bigger than 1, it is given, right? The limit is bigger than 1. Here what we are having, we have some quantity which is bigger than 1. Okay, let that be there. If this is the whatever may be the value of alpha, since we have taken supremum, we do not know exactly the limit n approaches infinity absolute of an for which we are taking the nth root will be same to the supremum or not, right? Sometimes supremum and infimum may different. Sometimes they are going to be same, since we are talking about limit. Okay, that we will see in the problems. Why am I saying like this, right? Then there is some sequence. Sequence of positive integers nk such that what absolute of ank approaches to alpha. Okay. Here what we are saying is that in the series we are able to from the terms in the series. Okay. Now instead of considering a series as a series, we may split that into a sequence as well, right? And from the sequence identify some subsequence. When you look at it, that converges to alpha. This is what we are meaning, right? This is going to be true. And what is this? Okay, and this tells you what? Hence the necessary condition for the convergence will not be satisfied here. What is the necessary condition for convergence? If an converges, then an approaches 0 as n approaches infinity, right? So this is the necessary condition for convergence. If this condition is satisfied, then this series may be convergent. Okay, for all the convergent series it will be true. Here what is happening? For infinite values of n, absolute of an does not approach 0. This is happening here. When this quantity is less than 1, when you take the power or something like this, that will approach 0. Okay, that has the possibility of approaching 0. Whereas this quantity is bigger than 1, and hence what? This is not happening. Hence summation an diverges. Okay, when this condition is not satisfied, you may come to a conclusion that your series is a divergent one. Now, for the third case, let us consider summation 1 upon n and summation 1 upon n square. I am considering two series now. What is okay, let me name summation 1 upon n as summation an and summation 1 upon n square as summation bn. Right? From these two, what is absolute of an? It is simply 1 upon n, since n is a positive quantity, and similarly absolute bn is going to be 1 upon n square. Right? Now what should we do? We have to take the nth root. So nth root of this is what we are going to look at it. So 1 power anything is going to be 1, and hence it is 1 upon n power 1 upon n, and here we are going to have n power 1 upon n whole square. Right? Now, now we have to take limit n tends to infinity and supremum. Okay, here this is not going to be any oscillating kind of thing. So, in order to take the supremum, it is going to be same. Even if we take supremum or infimum, it remains same. When you make your n approaches infinity, what is going to happen? That you may easily see here. Right? So, they are going to be same in both the cases. That is what? When you make your n approaches infinity, you will have this to be 1 and this also 1. Right? And here what is happening? Your alpha value is same in both the cases. Right? Whereas here your summation bn converges and summation an converges, but they have same alpha value. Okay, and this is why this test will not give you any information about the convergence of a series when alpha is 1. Right? And this completes the proof of this theorem. Let us see this example. Here in this example we are given with some series. We are going to find out the limit. Okay. Not only supremum, we are also to be find the infimum of the series. That is, we are talking about the nth root of absolute of an, for which we are going to find out the limit supremum as well as limit infimum. Let us see how to do it. Here, what is the general term? Okay, that is a question mark, right? First of all, we need to find out the general term of this series, and then we will have to find out those things. Okay, closely look at it. Here, if it is an odd term, it is 1 upon 2, 1 upon 2 square, 1 upon 2 cube, and it is going to be 1 upon 2 power something. Right? When it is even, we are going to have 1 upon 3 power something. So, the general term an may be written in two forms. If n is even, we are going to have something. If n is odd, we are going to have something. Okay. So if n is odd means we will have 1 upon 2 power something. Right? For this case, we are going to have 1 upon 3 power something. What is that something? That is a question mark now. Look at the terms. When your n value is 1, you have 2 power 1. It means we are it seems to have we are having n. Okay. When n is 2, we are having 3 power 1. So half of it. Let us take that way. Okay. Here the third term gives you 2 power 2. So here we are not going to have n. Right? So here fourth term we have 3 square. So half of 4 is 2. Similarly half of 6 is 3. So here the problem is solved. It is n upon 2. Okay. And here when n is 1 you have 1. When n is 3 you have 2. When n is 5 you have 3. Just add 1 to n and divide it by 2. You are getting it right. So it is 2 power n plus 1 upon 2. So we have found the general term of this series. Right? Now we will have to calculate this thing. What is it going to be? It is going to be simply the same. 1 upon 2 power n plus 1 upon 2 if n is odd, and 1 power 3, 1 upon 3 power n by 2 if n is even. Right? Since these are positive quantities, absolute still gives you the same value. Now we will have to take the nth root. So an to the power 1 upon n. What is it going to be? Okay. Now it will affect only in the denominator, as 1 power anything gives you 1. Right? and this is 1 upon 2 power n plus 1 by 2n, right? And similarly it is 1 upon 3 power n by 2n. So this is for the case when n is odd, and this is for the case when n is even, right? And that is what? It is simply 1 upon 2 power 1 by 2 plus 1 by 2n, and this is 1 upon 3 power 1 by 2 if n is odd, and this is when n is even. Now we will have to find out the supremum value. Okay, supremum of absolute of an to the power 1 upon n is what, and similarly what is the infimum value. Okay, and here what, it is a fixed value, right? Now we will have to compare this value with this. So under root 2 and under root 3, let us compare these two things. Here you have something extra, that is you are going to have what, 2 power 1 upon 2n, which is multiplied with this under root 2. Now let us make the comparison for these two things and try to conclude something. After that we will do the remaining calculations. Okay, here comparing these two, which is the largest value? This is the largest value, right? So only comparing these two quantities, I am not considering this. Okay, I am just comparing these two quantities and I am seeing this is the largest value. When I take reciprocal, what is going to happen? This becomes the largest and this becomes the smallest, right? So here I am having something extra. That extra gives you what? Even though you multiply that extra with this, it still remains the largest value. Okay. So while taking reciprocal, my supremum is going to be 1 upon 2 power 1 by 2 plus 1 upon 2n, and infimum is 1 upon 3 power 1 by 2. Now we will have to take the limit. Limit n approaches infinity, supremum of absolute of an to the power 1 upon n is going to be what? When you make your n approaches infinity, it is simply 1 upon 2 power 1 by 2. It is nothing but 1 upon under root 2. Similarly, when you make your n approaches infinity in the infimum, it is 1 upon under root 3. Right? Supremum and infimum value are different here. Right? Now let me give you another example. Let us take summation 1 upon n cube. Okay? Consider this thing. Right? What is going to be your absolute of an? It is 1 upon n cube. When you take power 1 by n, so it is going to be 1 upon n power 3 by n. Okay, you may also write it as 1 upon n power 1 by n whole power 3. Right? Or it may also be written as 1 upon n to the whole power 1 upon n to the whole power cube. You may write this way as well. Now, if you try to squeeze supremum and infimum out of it, both supremum and infimum are this value. And when you make n approaches infinity, in both the cases you are going to get 1. Right? The reason why I have explained these two are, while doing problems, we will not directly make use of the theorem that what we have seen. We are going to do something in a different, the same thing in a different manner. We will not look for the supremum value, we will look for simply the limit. Okay? When the limit is coming in two different ways, the supremum is different and the infimum is different. If we are getting two things in this manner, then we will consider the supremum. Right? That is why I have explained the theorem as well as gave you these problems. Now let us see another problem. In this problem, we are asked to examine the convergence of the series summation x bar n square plus 5n plus 7. Right? Now, let us find the nth term, that is x power n square plus 5n plus 7. It is directly given, and absolute of this is going to be what? The same thing, since x is given to be positive and n of course is positive quantity, and we will have to take the nth root of this quantity, which means x power n square plus 5n plus 7, for which we are taking the nth root, that means x power n square plus 5n plus 7 upon n. This is what we are having, and this may be written as x power n plus 5 plus 7 upon n. Right? Now we will have to take limit n approaches infinity to both sides. Now I am going to split this into three terms. Limit n approaches infinity x power n, limit n approaches infinity x power 5, limit n approaches infinity x power 7 upon n. Right? If you evaluate these limits separately, okay, I'll come from backwards. Limit n approaches infinity x power 7 upon n is going to be 1. When you make your n approaches infinity, you are going to have n power 0. Since x is a positive quantity, that quantity to the power 0 becomes 1. And limit n approaches infinity x power 5 remains x power 5 since it is independent of n. And limit n approaches infinity x power n, this value will depend on the value of x. Right? So this is going to be, this may be 0, this may be 1 or infinity based on the value of x. If your x value is 1, you are going to have 1. If your x value is smaller than 1, you are going to get 0. If your x value is bigger than 1, you are going to get infinity. This we have seen already, since summation x power n converges if x value lies between minus 1 to 1, and if x is equals to 1, for all other cases you are going to get divergent, right? This is what we have seen already while checking the convergence of this series. The same thing applies here, right? Put together, what are we going to get here? So, limit n approaches infinity, absolute of an to the power 1 upon n is going to be, here we are going to have three different things. Here we will have fixed 1 and x power 5, right? So now we will club these two things here, right? If you multiply 0 with these two quantities, you are going to get 0. So this limit is 0 if x smaller than 1. Okay, 1 times of x power 5 times 1, so it is x power 5. This is happening for x is equal to 1. Therefore 1 power 5 is also 1. This is 1 if x equals 1. Right? And what is happening? For this case, infinity times of anything is going to be infinity. So that we will not consider. That is infinity. Okay? So from this, the given series summation n square plus 5n plus 7 converges if 0 less than x less than 1. For this value it is going to be convergent, right? And for x bigger than 1 it diverges. And when the limit is 1, the test gives you no information. Therefore, we will have to substitute x equals 1 in the given problem and see what happens, right? When x equals 1, your summation x power n square plus 5n plus 7 becomes summation 1, right? Clearly, this series is a divergent one. Hence, the given series converge for x smaller than 1, right? And diverge for x bigger than or equals 1. And this completes the problem. Thank you for watching.